Okay, so yesterday I told you this form that reducible to linear form, linear differential equation. So let us see one example of this. So in such type of question, what you need to do, just put z equal to, if suppose at the right hand side y to the power something is there, so just put z equal to 1 upon y to the power n minus 1. Put z or v, whatever. Okay. So automatically you will get this form, and this is the linear differential equation. Okay, so let us solve one question of this. Question is, solve dy by dx plus 1 by x into y equals to x square into y to the power 6. Okay, so this is of the same form. This is y to the power n. Understood? So here first of all, what you have to put 1 upon y to the power n minus 1. N minus 1 means 6 minus 1 equal to z or v, whatever you want. Okay, if you want to suppose I am putting it v, so that you can replace. So this implies 1 upon y to the power minus 5 is equal to v. If you want to differentiate it, so take differentiation on both sides, so it will become minus 5 y to the power minus 6 dy by dx is equal to dv by dx, because I want to replace dy by dx. So dy by dx will be or y to the power minus 6 into dy by dx, that will be minus 1 by 5 dv by dx. And you do one thing, so these are the two replacement I will do. This is first replacement and this is second replacement. Now in this equation, what you do, just divide y by y to the power 6 to whole equation. Divide equation 1 with y to the power 6. So you will get 1 upon y to the power 6 dy by dx plus 1 by x y to the power minus 5 here, because y already there, that will be equal to x square. So now here you can do the replacement. This replacement you do, this replacement you do. Okay, so it will become minus 1 by 5 dv by dx and plus 1 by x into y to the power minus 5. This I can replace by v, so simply you can replace it by v x square. So this equation now has become what we require. dv by dx will be equal to minus 5 by x v is equal to minus 5 x square. Okay, so this is the linear differential equation. So in the linear differential equation, you can solve it easily. Sorry.
Sir.
Yes.
So please check that put y 1 by y6 y to the power 6 minus 1 that equations are deadline, because it should be plus 5 y to the power plus 5 should be
y to the power.
Please check 1 upon y to the power 6 minus 1 deadline. So please check.
Okay.
N minus 1. So in formula yesterday it was n minus 1.
y to the power n minus 1 na? Sorry, you have to put y to the power n minus 1, so 6 minus 1, so it will become 5. Here it is wrong. 1 upon y to the power 5 is equal to v. Okay, so now it is okay. Thank you. Everything is right now? Okay, note down it.
Done, sir.
Okay, so this is linear differential equation. You can compare it with the dy by dx plus py equals to q. Okay, so here p is equal to minus 5 by x, q is equal to minus 5 x square. Okay, so here so solution will be in term of v. Solution will be in terms of v, and that will be v into, actually I have to find out integrating factor. So first integrating factor will be e to the power integral p dx, e to the power integral p is minus 5 by x dx, e to the power minus 5 integral 1 by x is ln x. So it will be e to the power ln x to the power minus 5, and e ln will go, so answer is only x to the power minus 5. So that we can write here. So it will be v into integrating factor will be equal to integral q into integrating factor dx and plus c. This will be the answer. So v into integrating factor is x to the power minus 5 is equal to integral q is minus 5x square into x to the power minus 5 dx plus c. So v value you can put, that is v value is 1 upon y to the power 5 into x to the power minus 5 is equal to minus 5 will come out. Inside it will be x to the power minus 3 dx plus c. Okay, so it will be 1 upon x to the power 5, y to the power 5 will be equal to minus 5 into integral of this will be x to the power minus 3 plus 1 divided by minus 3 plus 1 and plus c. This implies 1 upon x to the power 5, y to the power 5 will be equal to, this minus minus will become plus, it is 5 by 2 into x to the power minus 2 and plus c. So this is the relation. So from here in the options how the relation he wants. Sometimes just in term of this only, there can be means solution can be in the form of some equation, or it can be some explicit, or it can be in the graph. So this is your answer. Note down this.
Done, sir.
Okay, so a little bit difficult question. I will solve one so that you will get some idea. This question is solve sin x into dy by dx plus 2y equal to tan cube x by 2. Okay. So this is already linear differential equation because this is fx and y function is not there. So this is the simple linear differential equation only. Okay. So what here I can do, just I can get rid of this sin x in the with this dy by dx. So what I can do, divide whole equation by sin x. So what it will become, dy by dx plus 2 by sin x. So that will become 2 cosec x into y is equal to cosec x into tan cube x by 2. Okay, so comparing it with the form dy by dx plus py equal to q, so you will get here p will be 2 cosec x, q will be cosec x into tan cube x by 2. So this is the p. So what will be integrating factor? E to the power integral 2 will come out cosec x dx. Now tell me, what is integral of cosec x dx? Can anybody tell? Don't remember? That is ln tan x by 2. You can check it. Okay. So this is ln tan x by 2. Okay. So if this 2 will go here, it will become e to the power ln tan x by 2 whole square. So e and ln will go off. So answer is tan square x by 2. Okay, so this is the integrating factor. Hence, solution will be y into integrating factor is equal to integration of q into integrating factor dx and plus c. So you apply here. So y into integrating factor is tan square x by 2, that will be equal to integral q q. Okay, q is cosec x into tan cube x by 2 into integrating factor. This integrating factor is tan square 5 by 2. So I can make it 10 to the power 5 x by 2 dx and plus c. So like this we will solve it. Okay. Note down this. Done.
Yes, sir.
Okay. So next we can take. See here. This is tan x by 2, na? So this form also we can change in x by 2. Now what is this? This is 1 by sine x. And to make it x by 2, it will become 1 by sine 2 into x by 2. So what is the formula for sine 2a? 1 upon 2 sine a cos a. 2 sine x by 2 cos x by 2. So that I will put here. So it will become y into tan square x by 2 will be equal to integral 1 upon 2 sine x by 2 into cos x by 2. So what I will do, this tan cube x by 2 I will keep separate, and tan square x by 2, that I will write sine square x by 2 divided by cos square x by 2. Okay. And here what we'll do, one more thing we have to do, put tan x by 2. Put tan x by 2 equal to t. So when I differentiate it, this implies sec square x by 2 into, once you differentiate x by 2, that will give you 1 by 2 into dx, that will be equal to dt. Okay. So from here, this cos square x by 2, this will become sec square x by 2 into dx. So that will become dt. And from here, 1 sine x by 2 will be cut, and that or you can do like this. No need to make 2 here. You just take it tan 4x by 2, and then it will become sine x by 2 by cos x by 2. That is sufficient. So what will happen? This sine x by 2 cancel, and this cos x by 2 into cos x by 2, that will become sec square by 2 into dx, that will become dt. So it will become y into t square is equal to integral 1 by 2 will come out, and it will be just t to the power 4 dt. Okay. And that you can integrate easily. So it will become 1 by 2 into t to the power 5 by 5, and plus c is also there. So like this you can do. Okay, so this t square, because I want to get the answer in y, so y will become 1 by 2 t to the power 3 actually it will become 1 by 10, no? One second, this 2. This 1 by 2 also I have to utilize, na? So this 1 by 2 will be gone with that sec square x. So 1 by 2 will not be remaining here. Okay, so it will be t cube by 5 and plus c t to the power minus 2. Now put the value again back. What is the value of t? So y will be 10 cube x by 2 1 by 5 and plus c into 10 to the power minus 2 x by 2. So this is the answer. If boundary condition are given, you can put that, you will get the value of c, then your final answer will be with you. Okay, so this is the benefit of boundary condition. Note down this.
Done, sir.
Next question. Solve dy by dx plus y tan x equal to sine 2x. Here boundary condition is given, y at x equal to 0 is 1. Okay, so how to solve this? So here again by comparing with dy by dx plus p y is equal to q. So y is this, so this will work as p. Here this will work as q. So here p is 10x, q is sine 2x. So integrating factor will be e to the power integral p dx integral e to the power 10x dx. Tell me what is the integral of 10x? Anybody?
X square.
No.
So log of secant x.
ln sec x. Prem Rajna. No.
Premraj is absent.
Okay. So who told this answer? No, nahi batayega, no problem. So it is sec x. Okay. So this is the integrating factor. Hence, solution will be y into integrating factor y into sec x equal to integral of q is sine 2x into sec x dx. and plus c. Now you can solve it easily. This sine 2x you can write 2 sine x cos x, and cos x into sec x will become 1. So it will remain only 2 integral sin x dx plus c y into sec x. Okay, note down this. Done.
Yes, sir.
So this integral of sin x is minus cos x. So y into sec x equals to minus 2 cos x plus c. Okay. So what you have to do here now? Now put boundary condition. Okay. So what is that? At x equal to 0, y is equal to 1. So 1 into sec 0 is equal to minus 2 cos 0 plus c. Okay, so sec 0 is what? 1. And cos 0 is 1. It means c is equal to 3. So this value I can put here. Hence, y into sec x equals to minus 2 cos x plus 3. So now y will become equal to minus 2. You divide by sec x here, it will become cos x. So minus 2 cos x square x plus 3 cos x. So this will be the answer. Okay, note down this.
Done, sir.
Okay, sometime question can be made with the help of some other topic. So this question I am taking from other topic. A circuit is given. E naught sin omega t. This is a inductor. Here voltage drop is V1. This is a resistance. Here voltage drop is V2. Okay. So here you have to find the current I. This is the question. So this is a differential equation question. How to make it? Now here total voltage, this V1 and V2, this drop is equal to E0 sin omega t. First of all, you have to note that. Means this total voltage will be equal to V1 plus V2. here V1 plus V2 is equal to E naught sine omega t. Now this V1 is the voltage drop across inductor, and voltage drop across inductor we can write L di by dt plus this V2 simply we can write IR if R is the resistance and here L is the inductor. So this V2 I can write simply IR. Okay, then it is equal to E naught sine omega t. So this has become a linear differential equation. So it can be written as d by dt plus R by L into I is equal to E naught sine omega t. Okay, now here you can compare this equation. Here I and t are two variable. Okay, so this I is the dependent variable, t is the independent variable. Understood? Like y and x, here they are playing the role of I and t. Okay, so here comparing with di by dt plus p into I is equal to q. So if you compare that, so here p will be equal to R by L and q will be equal to E naught sine omega t. This is a complete function. So I can do the same way. Integrating factor will be e to the power p dx. Sorry, p e to the power integral p into dt is there. So integral R by L dt. R by L both are constant. So e to the power R by L into t. This is the answer. Okay, so note down this. If any step you are not getting, please tell me.
Done, sir.
Okay. Hence, we can write. So what will be solution? Solution will be I. So I into integrating factor e to the power R by L into t is equal to integral q. Q is E naught sine omega t into integrating factor e to the power R by L into t and plus c. Okay. So here what I can take, E0 will be coming out, E0 by 1 second. Sorry, here R by L dt. Okay, this is okay. Sorry, here I have to put E0 by L because once we are dividing with L, na? So here also it will be. So Q will be E0 by L. Q will be E0 by L. So E0 by L will be going out and it will be e to the power R by L into t into sine omega t dt and plus c. Now this type of formula we have done in complex analysis. Do you remember? E to the power ax into sine bx dx. We have done it. So what was the formula? The answer will be e to the power ax divided by a square plus b square, a sin bx minus b cos bx. So this was the formula. So this formula will be applicable here. So I can use E naught by L into e to the power ax. A is what? R by L. So e to the power R by L, and x is here t. That is same. Divide by a square plus b square means r square by L square plus b is working as omega. This much into a. A means r by L into sine omega. In place of x it is t minus b. B is omega into cos bx omega into t. This will be the answer. Now you can simplify it. So I into this much. So what you can do, e to the power RL by t, this side also, so it can be cancelled. So I will become equal to E naught by L into, or simply you can say this L square. You can take here LCM. You can take here LCM. So it will become R square plus omega square L square, and L square will go up. So it will become E0 into L square divided by L into, this will become R square plus omega square L square. Like this it is. So this L to this L cancel. So it will be E0 L by this much. Okay. Now it will be R sin omega t by L minus omega cos omega t. Now what I am doing, L I will multiply inside, and one more thing I will do, because I know one more thing here. If this type of circuit is there where inductor and resistance both are there, so we can make a triangle. Okay, because in such cases voltage is leading to the current. Voltage is leading to the current. If capacitor is there, then voltage lags behind the current. With that property, we can make that these both are not in phase. V1 and V2 are not in phase. Okay, it is due to that because R, L and omega L. Suppose this is R and this is omega L. Okay, so they will make a angle phi here. So this value will be R square plus omega square L square. So this is the relation in between them. Okay, so what I can do, this quantity is important here because that is the omega L is the impedance of your inductor, R is the resistance of this resistance, and if I want to know the what is the resultant, so resultant will be R square plus omega square L square. So that value is important. So I can create that value. Okay, otherwise as per this LDE linear differential equation, question is solved, problem is solved. Okay, but sometime further extension in the electronics also, because both the things are applied here. So what I can do, L I will multiply inside, it will become E0, and I can make it under root R square plus omega square L square. So into under root r square plus omega square L square, that I can multiply inside. So once L is multiplied inside, L to L will cut. So it will become R sin omega t and divide by under root r square plus omega square L square. Means 1 under root this r square plus omega square can be written as under root into under root r square omega square L square into under root r square plus omega square L square. One of that I am taking inside, minus omega by under root r square plus omega square L square. Now this is under root r square plus omega square L square. This angle is phi. This is the phase difference between both of them. This is omega L, this is r. Okay. So first note down up to here. Now you tell me this r divided by under root omega square L square, what it will be? R divided by base divided by hypotenuse cos. Okay, so it will become cos phi, and this omega divided by this.
But sir, there was an L there with the term R upon L sin omega t.
L na L will cancel. This L I am multiplying inside. L to L will cancel, and this L will go with here omega L. Understood? Note down it. Done?
So what happened to the exponential?
Left hand side exponential and right hand side is also exponential. So what to do? It will be cancelled, na?
Yes, sir.
Done?
Done, sir.
Okay. So it will be E0 by under root R square plus omega square L square into this R divided by R square under root R square plus this R divided by this, that will be give you cos phi sin omega t minus this omega L by this much, it will give you sin phi cos omega t. So this you can make sin A cos B minus cos A sin B. Okay, so you can write it like this: sin A cos B minus cos A sin B. So that formula will become, and this E0 by this much, this is a constant. This constant I can say that this is the, because this is the impedance and this is the total resistance, total voltage. So voltage by resistance will give you current only, and that value is maximum, that is known as I naught. So I equal to I naught into, it will become sin omega t minus phi. So this is the final answer. Okay, here electronics knowledge is also required, and this LDE, this is the question of LDE. Okay, actually here I forgot to tell you that there will be some constant also, and that constant by the analogy, that constant will be decided by the analogy of this exponential term. So on that basis we can take or you take it C only, no problem, you take it C only, But when you are dividing the whole equation e to the power r by l into t, okay, so that time it will become c into e to the power minus r by l into t. This will be the constant term, c into e to the power minus r by l with t. Okay, now you see here, because this is exponential term, so as time passes, so this term will go to nearly 0. As time passes, okay, tend to 0. So with a at greater time, it will reach nearly 0. So we can leave this. So the final answer is I naught sine omega t minus phi. So like this you can do. Okay, so quickly note down this. Done?
So after
Yes,
some
sir.
time the inductor won't affect.
What happened?
The inductor is not having any effect in the final equation. Only during that, only the c e to the power r by l is there, right? And the peak current.
This term, na?
Yes, sir.
No, I told you, na. As time passes, so it will reach to 0. So we can leave it. Actually, it is as per the adjustment of options. If it is there, then it will be there. If it is not there, so that can be the reason. That's it. So number 6, exact differential equations. So this type of equation can be there, exact differential equation. Form of these equation are, they will be looking like m dx plus n dy is equal to 0. Okay, then they are looking like this, but to declare it exact differential equation, we have to check it for one test. And what is that test? Means such type of equation will be exact differential equation if del m by del y is equal to del n by del x holds good. If this hold good, then only you can say that this is the exact differential equation. Okay, and m and n, what are the m and n? They are the function of ny, sorry, x and y. Here m and n can be any function of x and y, whether they are function of purely x, purely y, or both combination x and y. Okay, now this is the condition here. So then solution is integral of m dx plus integral of n dy is equal to some constant c. Now when you are integrating m, you have to treat y as constant. When you are taking n, in that your term should not contain x, or you can leave the x terms. So here n is terms, n is the terms which are not containing x, terms not containing x. These are the two things you have to remember. M should be such that here take y as constant, and n should be such that it should not contain any x term. That's it. So this will be the solution. Okay. Once again, form of this equation is m dx plus n dy equal to 0, and it will be declared exact equation if del m by del y is equal to del n by del x. This is equal. So for such kind of thing, we have to take solution integral m dx plus integral n dy equal to c, where in the m treat y as constant when you are integrating it, and take n such that x term should not be there. That's it. Note down it.
Done, sir.
Let us take one question of this. Solve 1 plus log xy dx plus 1 plus x by y dy is equal to 0. So this is the function of xy. This is also the function of xy. Okay, no problem. But it is looking like m. It is looking like n. Understood? It is m dx plus n dy equal to 0. So this is the same kind. So here m is 1 plus log xy. N is 1 plus x by y. Okay. Check. So this is our test. Check del m over del x. Sorry, del m over del y is equal to del n over del x. So this we have to check. Now differentiate m with respect to y. It will become 1 plus 1 upon xy into with respect to y na, so it will become x. That should be equal to del n over del x. Del n over del x, if you do, it will become 1 plus 1 upon y. So this x to x cancel. So it is also 1 upon 1 plus 1 upon y. This is also 1 plus 1 upon y. It means it holds good. Your answer holds good. Okay. So given equation is exact differential equation. Hence, solution will be integral m dx plus integral n dy is equal to c. Here you have to treat y as constant, and here leave all terms containing x. So these things you have to remember. Note down it first. Or here I can write. So integral m dx. M is what? 1 plus log xy dx plus integral n dy. N is what? This one. Here term containing x, this is x upon y. So you have to leave it. So what is left? Only 1 is left. So 1 dy is equal to c. So now you can integrate it. So it can be break 1 dx and ln xy dx. So 1 dx will give you x plus integral log xy dx or integral log xy dx and plus integral 1y is equal to c. So this is x plus y, x is this and y is this. Now what is the integral of this? Can anybody know the formula? See here, integral log x is equal to x log x minus x. This is the formula. So by this formula, this integral will be plus xy log xy and minus xy. Equal to c. Note down this. Sorry, this integral. Okay, if it is because here what is happening here, this is not purely x. It is with the x there is some constant, because we have to treat y as constant, so some constant is there. So for that, when you are doing the integration with that constant, you have to divide it. So divide y also will be there. It is like something integral.
E to the power x. Exponential also similar. E to the power something into x.
Okay. So you understood it, no, miss? You have to divide that constant. That's it. That I mean to say. If you are integrating this and with that there is a constant, so then that constant you have to divide in the whole integration. Formula you have to use this. Note down it.
Done, sir.
So we can simplify it more. It will become x plus y plus x log xy minus x is equal to c. So x to x cancel. So answer will be x log xy plus y is equal to c. So this is the answer. So like this you can solve such type of equation. Okay, so note down this quickly. So then we will go to some equation which are not exact but can be reduced to exact differential equation.
Done, sir.
Okay. Okay. Next is ordinary differential equation reducible to exact differential equation. Okay, so these equation also will be looking like form of equation is same, mdx plus ndy is equal to 0. But problem is what? Del m over del x is not equal to del n over, sorry, del m over del y is not equal to del n over del x. Means this test does not hold good. So this is the problem here. So such equation are not exact differential equation, but here I will not use but. This is the form of equation, and del m or del y is not equal to del n or del x. So such equation are not exact differential equation, but can be reducible to exact differential equation. Okay, by multiplying integrating factor. Or you can write by multiplying suitable integrating factor. Suitable integrating factor. Okay. Now, how to find out that suitable integrating factor? Number one, if that you have to check, if del m over del y minus del n over del x divided by n is equal to some function of x. Okay, if this is some function of x, then use integrating factor as e to the power integral fx dx. Okay, so this is one condition. And if it is equal to fy, then you have to use integrating factor that. So that's why I am telling you here word suitable. So multiplying with suitable integrating factor. Number second, if del m over del y minus del n over del x divided by n is equal to fy, then use integrating factor fy dy. Okay, note down this.
There is denominator n in both cases.
Huh?
Denominator is n.
Sorry. No. Here you have to take m. Because it depend upon this differentiation. Because m you differentiate with y and you differentiate with x. So here you have to use m. Okay. So now you write it.
Done, sir.
And third thing also can be there. Third thing is that your function is fxy. Okay. If function is means combination of both f, x and y. If function is fxy, means any function. If you try this, that is also fxy. If you try this, that is also fxy. So just I am telling about the function. If function is fxy, then directly you can take integrating factor equal to 1 upon mx minus ny. That you can take the integrating factor. Now you multiply this integrating factor with the whole equation. Then automatically your equation will be converted to exact differential equation. Okay, so you can note down it. This is done now.
Yes, sir.
Okay, so you can note down this line also, then we will solve one problem. This is the question, you have to solve it. Okay, so here compare with this m dx plus n dy equal to 0. So here m will be x square minus y square, n will be 2xy. Okay, 1 second. Now here check del m over del y equal to del n over del x. This implies del m over del y. It will become x, sorry, del m over del y, na? It will become minus 2y equal to del n over del x. It will become y. Okay, so 2y is not equal to that. Okay, so given equation is not exact differential equation. Now check again. Next condition is what? You have to check del m over del y minus del n over del x divided by n is what? So del m over del y and del n over del x, del n over del y is minus 2y and minus again 2y and divide by n. N is what? 2xy is equal to what? This is minus 4y divided by 2xy. So 2 to 2 and y to y cancel. It is minus 2 by x. Okay, and this is the fx. Function is fx. So here integrating factor will be e to the power integral fx dx. Fx is minus 2 by x dx. It means it will be e to the power minus 2 ln x. So minus 2 can go on this power. It will be e to the power ln x to the power minus 2. So e to the power ln will go off and it will become 1 upon x square. So this is your integrating factor. 1 by x square is the integrating factor. So this integrating factor you can multiply in whole equation. This is my equation number 1. In that I will multiply. So first note down it.
Done, sir.
Multiplying integrating factor in equation 1. Okay, so that will become here 1 by x square into this much plus 1 by x square into this much So 1 by x square into x square minus y square plus 1 by x square into 2xy dx is also there, no? And it is 2xy into dy is equal to 0. So multiply this inside, it will become 1 minus y square by x square into dx plus it will become 2x by y dy is equal to 0. So here if you compare it, this will work as m now, this will work as n now. Okay, check del m or del y is equal to del n over del x or not. This implies del m or del y. So this thing you differentiate with respect to y, it will become minus 2y by x square is equal to del n over del x, del n over del x 2 by y.
Sir, it's y by x.
Please
in
check
n.
n value.
Okay, y by x, na 2y by x. So you differentiate y by x, it will become minus 2y by x square. So now it is satisfying. Okay, so it has become satisfied. So this is my equation number 2, as equation 2 is exact differential equation, and its solution will be integral m dx plus integral n dy is equal to constant. Now put here integral m dx, condition you know, integral m dx 1 minus y square by x square dx plus integral n dy. In n you have to leave the term. Okay, so here you have to leave the term which contain the x, so that term will become 0. Now you can integrate it. It is 1 dx. 1 dx will give you x minus y square because treated as constant. So this is integral x to the power minus 2 dx is equal to c. So it will become x minus y square into x to the power minus 2 plus 1 divided by minus 2 plus 1 is equal to c. Okay, so note down this. So it is x to the 1 upon x, you can say, or minus minus will become plus x minus y square by x, y square by x. Yes, so solution will become x minus y square by x is equal to c. So this is a solution. In what form they want, you can convert it, or you can do it y square by x will be equal to x minus c. So y square will be x into x minus c. That form will be better. Or y will be under root of x into x minus c. This is the final answer. Note down this.
Done, sir.
So one different variety of question I am taking. Solve 2x y dash equals to y square minus x square. Okay. So this question has been asked. Find general solution, and number second, plot it. Whatever the general solution has come, you have to plot it. Okay. So this type of question, how you can do, you can put up some mind. This is y dash is dy by dx. So whatever with this, you have to make it with this dy by dx should have coefficient 1. So then only you can guess how the question can be solved. So to make that, you can write dy by dx will be equal to y square minus x square divided by 2xy. Okay, and this type of question I have already told you, here degree is 2, in denominator also degree is 2. So it means it is a homogeneous equation. Homogeneous differential equation. And how to solve such type of problem? Put y equal to vx. Then if you put that, so then it will become a variable separable. So put y equal to vx means dy by dx, you have to put x dv by dx and plus v. Okay, so you have to put it, so it will become x dv by dx plus v will be equal to y square. In place of y, you have to put v. It will become v square x square minus x square divided by 2xy. 2 into x into vx. So it will become x square. So x square cancel. So it will become v square minus 1 divided by 2v. Okay. So x dv by dx will be equal to v square minus 1 divided by 2v and minus v. So now you can take LCM. It will become v square minus 1 minus 2v square divided by 2v. So v square minus 2v square means minus v square will be there. So minus 1 plus v square I can write divided by 2v. Okay. So from here now I can do the variable separable. Note down this first.
Done, sir.
Okay.
Sir,
Yes.
before problem, I got x plus y squared by x equal to c.
Miss, you have done solution.
Yes, sir.
So
Before problems.
before problem means
Scroll up,
Previous question, sir.
okay,
previous.
previous. This one, what you get?
X plus y squared by x equal to c.
X plus y square by x equal to c.
Yeah.
Uh,
Actually, x power minus 1 by minus 1, that will be minus 1 by x only, sir.
x to the, this is x square minus y square into x to the power minus 1. Yes, yes, yes. It is okay. Okay, now here by variable separable. So it will become dv by everything will come here. It will become 2v by 1 plus v square into dv will be equal to minus of 1 by x dx. Okay, so now you can integrate it like this. There is no issue, because once the differentiation of denominator is put in numerator, so then you can take it as ln of denominator. Okay, this method if you know, so then it is easy. If you don't know, so then you can put v square equal to 1 plus v square, this whole term you can put equal to t, so then you can do. Okay, so choice is yours. Just I am integrating it. So integration of this, because if you differentiate denominator and that is available here, so then simply it is ln of denominator will be equal to minus of ln of x and plus c. But I told you if answer is in ln, so constant also you can take in term of ln. So it will become ln c by x. Ln c by x, because this is minus, so it will go in denominator here. Okay, so this is ln 1 plus v square. So now you can compare it, comparing on both sides. So 1 plus v square is equal to c by x. Now put the value of v, because we have put y equal to vx, so v will be y by x. So it will be 1 plus y square by x square will be c by x. Okay, so this is the form. Now here what you can do, you can take LCM here. It will become x square plus y square divided by x square equal to c by x. Now this x square will go there. This implies x square plus y square will be equal to cx. Okay, and this also I can take on left hand side, x square plus y square minus cx is equal to 0. So this is the equation. This equation I have to further manipulate. So first note down up to here. If only solution is asked, so then it is okay. If you have to ask, you have been asked what are the plot, you have to plot it. So means then you have to go further.
Then, sir,
Okay, so question number B, you have to plot it now. This is x square plus y square minus cx is equal to 0. So you have to plot it. Actually, it is giving me some intuition. It is giving me some intuition that it can be the equation of a circle. So how? Because I know that equation of circle can be like this: x minus h whole square plus y minus k whole square is equal to r square, you can say. Okay, So then this circle will have H and K is the origin in that circle. Understood? So this is the standard form of a circle, and R is the radius here. This is a standard form of circle. So can I make my equation in that form? That you have to think. So now what you can do, x square minus cx plus y square is equal to 0. So simply with y I cannot do anything. I can make it y minus 0 whole square is equal to 0. But with this I can do something. What you can do? You can put it like x minus c by 2 whole square. If you make it, now you open it, x minus c by 2 whole square. If you open it, it will become x square plus c square by 4 minus twice into x into c by 2. So 2 to 2 cancel. So that will become x square plus c by 4 minus xc. So x square minus xc, that is already available. What is not available? C square by 4. That you have taken extra inside that. So for that, minus of c square by 4, again you have to write here, because this term is giving you something extra. So that extra term I have to take minus. So now it will become x minus c by 2 whole square plus y minus 0 whole square will be equal to c square by 4. And this c square by 4 I can write c by 2 whole square. So equation has become x minus c by 2 whole square plus y minus 0 whole square equals to c by 2 whole square. So now compare it with the standard format of circle. If you compare it, so then origin will be c by 2 and 0, and radius will be
C by 2.
c by 2. So like this you get. Now you can plot it. So we can plot it simply. X, y. So origin will be where? C by 2. Suppose this is the point c by 2, and y value should be 0. So this is that point. With that you have to take radius c by 2. So once you take radius c by 2, so it will touch here. Okay. So this is a circle. So is this the answer? No. In the option it will be there, it is a circle or family of circle. So once c is there now, because c is my constant, and that constant can take any value. It can be minus also, or you can say if different value of c are there, then it will give you a family. You can mention it in the question. If he asks you if different values of c are available, if only single value of c is available, so then single answer will be there, single circle that I have plotted. If different values of c are available, then we get family of circle. Okay. Sometime if c can be minus c by 2 also, so then it will be a circle, but it will touch to this. Okay. If suppose at some time c value is 3, at some time c value is 5, sometime it is 9, like this. So if c value is increasing, so then this also can be a circle. And in negative side, this also can be a circle. Okay. So you can say that for different value of C, we get family of circle. So this is the answer. If only single value of C is there, so then single circle. So note down it first. But here one thing you will notice that for this circle now, for bigger circle, the origin also will change, because this is C dash by 2 now. This is minus C dash by 2 and 0. Okay. Means origin will also change if your C is changing. C is bigger. Note on this.
Done, sir.
Okay, quickly you can make this plot also.
Done, sir.
Okay, so this is all for today.